Hello everybody. I'm going to go over an applied optimization problem. Hopefully it'll be similar to the one that you're going to have on the quiz tomorrow, but I can't promise that. So I'm going to go through this one and we'll see how it works out for tomorrow. So the question is, you're making a rectangular garden with one side being a rock wall and the rest being made from a wire fence. You have 100 feet of wire fence to use, and you're trying to find out what the maximum area you can make is going to be. So first thing and the most important thing is to draw a picture. So you have a rock wall, right? So there's not going to be any fencing going here, just rock wall. Get that detail in, bam. And then the rest of it, it's going to be a rectangle. And that's your picture. Next step to making the picture is labeling everything. You're going to want to get some variables in there so you can actually do math. So easiest way is to just label each side. So we're going to make that x, we're going to make that y, and then the other side is also going to be x because they're both, it's a rectangle. So this side and then this side is equal. And what you're doing with optimization is you're using derivatives to find either the maximum or the minimum of a function. So I'm going to go over that real quick. So to find a maximum or a minimum of a function, let me write that. To find a max or min of a function, you do a couple of steps. First step, find the derivative. For optimization problems, it's usually really easy derivatives. I'm pretty sure this one was pretty easy. This rock one that I'm doing right now is a pretty easy function to find the derivative of. There's no integration required, so that's very, very fun. Once you find the derivative, what you're going to do is set the derivative, I'm going to abbreviate it, equal to 0. Okay? And what you're doing here is when you're setting it equal to 0, you're finding the point at which the sign of the derivative is changing. So if it's going from either negative to positive, or if it's going from positive to negative. Draw little arrows. Okay? So if the derivative was going from negative to positive, so the derivative is going to negative, and then, no, I don't want to. So it's going downwards. It's going to reach 0, and then it's going to start being positive again. So right there, oh, that's not a good place. Right there, that's a better place. So that's when it reaches 0. So when you find when the derivative is equal to 0, then you know that's the changing point of the slope. And then for this one, for the positive to negative, you have a positive slope, and then the slope becomes negative, and then right there it's 0. So you're finding the point at which is 0, so you can see if it's a maximum or a minimum, and then what x value this slope being 0 occurs at. So hopefully it'll make more sense once we actually go through the problem. So once you set the derivative equal to 0, you're going to want to solve for x, or whatever variable. Solve for your variable. And then once you get that variable, that's going to be it's going to be x, because it's going to be a coordinate system. Let's just call it x. Solve for x. Once you get that x, that's going to be your x coordinate, and to find your y coordinate, all you have to do is plug it back into your original function. Don't plug it back in the derivative. Plug it back in your original function. So plug x back in original function. So, and then depending on what the question is asking for, you might have another step, but basically it could either be, this question is asking for what the maximum area is. It could also ask what the dimensions are that give you the maximum area. So make sure you're careful with that. So now that I kind of explained it, I'm going to move this all away. I'm going to move it down, right? Sure, right there. And now I'm going to start working on the problem. So we're trying to find the maximum area, right? So to find the maximum or minimum of something, you take the derivative of it. So we have to make the area into a function. So a equals, what does a equal? It equals length times width. So our length times width, x times y. And then we take the derivative of that. So if we took the derivative of this, it'd be a prime, and then you'd have to do the product rule right now. And there's two different variables, so it's too much. It's not, there's an easier way to do it. So once you have this function, you got to try to figure out another function. So looking at your picture and then the data that they give you, you have to try to think of another function. So this is all just like trying to think. There's no way to be able to like teach this. Just try to think about it. So from this question, you know that you're given 100 feet of fencing. So that means that this x, this first x, this second x, and then this y, whatever it's going to be, no matter what, it's going to be equal to 100. So that means x plus y equals 100, and simplified. 2x plus y equals 100. And now you're going to want to substitute something into this equation to make it all in terms of x. So to do that, you can solve this equation for y. So y, let me write it out again. You want to get y by itself, all you have to do is subtract 2x from each side. And then you get y equals 100 minus 2x. And now you can take that right there and plug it in for that y. So you'll get a equals x times 100 minus 2x. And then to make things a little bit easier, I'm just going to distribute that x. So it's going to be 100x minus 2x squared. Okay? And from here, we just kind of go through the steps that are down here. Find the derivative, set the derivative equal to 0, solve for the x, and plug x back into the original function. So, number 1, finding the derivative of 100x minus 2x squared. We're just going to use the power rule. Oh god, whoa. Power rule. A equals 100. A prime equals 100 minus 4x. Okay? And now, I don't know why I checked all these. We haven't done them. We did this first one, so we found the derivative. Next, we're going to set the derivative equal to 0. So 0 equals that. Wow. Next step, complete, solve for x. So x is just going to be, let's do that. It's algebra at this point, really. 4x equals 100. So x is equal to 25. So now we have our x coordinate. So this x that we have is the point at which the function is switching its slope from either negative to positive or positive to negative. Looking at your formula, there's two ways you can tell if it's going to be a maximum or a minimum. The one way to tell is to take your point, put it on a number line, and then it's going to be 25. And then you would take a number from here, so we'll do 24, and a number from here, 26. Plug that into the derivative and see if it's positive and negative or negative and positive. If you don't want to do all that work, you don't have to in some situations. You can look at the function, the original function, so you see that it's a quadratic, but the x squared is negative. So it's going to be a parabola opening downwards. So that means we're going to have a maximum. So we're good. We know that wherever at x equals 25, we know that it's a maximum. So to find the value of the area at x equals 25, we plug it into here, right? So that's going to be x, but we don't have y. Oh wait, we do, because we made a function that doesn't need y. So now we just do that times 25 minus 2 times 25 squared. And that, I'm going to totally do this off the top of my head and not using the computer or anything. This ends up equaling A equals 1,250 feet squared. So that's your maximum area. Real quick, if it was asking for the dimensions, all you'd have to do is you would just plug it into this equation right here. So you know x is 25, so it's 25 plus 25 plus y equals 100. So 50 plus y equals 100. So y equals 50. And then you know your dimensions are 25 by 50. And then feet. Don't forget your units. And then 25 times 50 is going to be equal to that, 1,250. So that's an optimization problem. I'm sorry if it's all over the place. I'm trying to cover as much as I can before the quiz. If you guys have any questions, shoot me a text on Remind. I'll be more than happy to help you. I hope this really helped you guys, and if not, I'm very sorry to disappoint. If anybody makes fun of me for my voice cracking when I said that one word, Dr. Gubkin is gonna give you an automatic F for the course. Thank you. Have a good day.